we'll be using the substitution rule in integration to solve for more complicated integrals. So we have an integral with a composite function. Say we have f, and then our inner function is g of x. When we have an inner function like this and we want to take the derivative, we have to have g prime x here, dx using the chain rule. Okay, now say we want to make a substitution to make this integral easier for ourselves. Well, we can make u equal to g of x. Then, if we take the derivative of u, we can get du dx, which will be equal to g prime x. And now du is equal to g prime x dx. Well, then our original integral becomes integral of f of u, because of the substitution we made over here, times g prime x dx, which we've now found to be du. And this is our substitution rule. So if we move on to an example, we have x over 1 minus 4x squared. And we notice that x is the inner function of 1 minus 4x squared. 1 minus 4x squared could be considered a composite function of the function x. So let's call our composite function 1 minus 4x squared u. So let u equal to 1 minus 4x squared. Well, now du dx is going to be equal to 0 minus 8x. And then we can find that dx is equal to minus 1 over 8x du. So let's plug all of this back into our original integral. So this integral can then become the integral of x over the square root of u now, because we've defined the substitution, times dx, which we've determined to be this. So times minus 1 over 8x du. And now we have a situation where these x's can cancel, and we're going to be left with a nicer integral, minus 1 over 8 integral of u to the minus a half du. This becomes minus 1 over 8 2u to the half plus c. Well, now we can write this as minus 1 over 4 u to the half plus c. And the only thing left to do is to substitute this u back in terms of x. So our final answer is going to be equal to minus 1 over 4, 1 minus 4x squared to the half plus c.